In section 5.8, we're solving equations and applications using polynomials. So we are going to utilize the zero factor property, which says for all real numbers a and b, if a times b is 0, then a is 0, b is 0, or both are 0. So the only way we can get to 0 with multiplication is if one or both of our terms is 0. And so in order for this to work, it has to be set equal to 0 first. So for example number 1, the first thing you want to do is subtract 100 from both sides. So we have x squared plus 15x minus 100 equals 0. Now from here, we're going to factor it so we can set each factor equal to 0. This is not one of our special forms, and so we have a is 1, b is 15, and c is negative 100. So let's go ahead and do the AC method. We have 1 times negative 100, which is negative 100. That means we can have one positive and one negative number. Factors of 100, I have 1 and 100, 2 and 50, 4 and 25, 5 and 20, 10 and 10. The goal is to get to positive 15, which means that the bigger number is positive and the smaller is negative. So everything on the left is negative and everything on the right is positive. And so the combo that gets me to positive 15 is negative 5 and positive 20. So we bring down our leading coefficient and split our x's. And we put our missing pieces of negative 5 and positive 20 in our blank space. And this is still equal to 0. The last step is to divide out whatever they have in common. And so in either case it's a 1. So we have x minus 5 times x plus 20 equals 0. We want to set each of these binomials equal to 0. So x minus 5 equals 0 and x plus 20 equals 0. And we'll solve these individually. The first one, we're going to add 5 to both sides. And so it cancels on the left, and we get x equals 5. And for the second one, we're going to subtract 20 from both sides. And so it ends up canceling on the left, and we get x equals negative 20. So our two solutions are x equals negative 20 and x equals 5. Let's go ahead and try another one. For example number 2, it says to find the roots. That is the exact same process as finding the solutions. We just have two different words that we can use. First thing we want to do is we are going to distribute the 7 to both pieces. So we have 6x squared plus 4 on the left, and then 7x plus 7 on the right. We again want this set equal to 0 so that we can factor and solve it. So I'm going to subtract 7x and subtract 7 from both sides. And so on the right-hand side, it cancels. And on the left, I have 6x squared minus 7x minus 3. We're going to approach this the same exact way. Do I have a GCF that I can take out of these? I don't, so my A is 6, my B is negative 7, and C is negative 3. So A times C, we have 6 times negative 3, which is negative 18. We have 1 plus and 1 minus. And then we've got our factors of 18. 1 and 18, 2 and 9, 3 and 6. We want to get to negative 7, which means that the bigger number is negative and the smaller is positive. So the left-hand side is going to be positive while the right is negative. And the combo that gets me to negative 7 is 2 and negative 9. And so we bring down our leading coefficient, which is 6, and we split our x's. We have our missing pieces of plus 2 and minus 9. And then we divide out whatever they have in common. So between 6 and 2, we can divide out a 2, and between 6 and 9, we can divide out a 3. And so I end up with 3x plus 1 and 2x minus 3 equals to 0. We want to set each piece equal to 0 so we can solve it. So 3x plus 1 equals 0, and 2x minus 3 equals 0, and then solve them accordingly. So for this first one, we're going to subtract 1 from both sides. We get 3x equals negative 1. And then we want to divide both sides by 3. And so we get x equals negative 1/3. Now let's solve the other one. First thing we're going to do is add 3 to both sides. We have 2x equals 3, and then we're going to divide both sides by 2. And so we end up getting that x is equal to 3/2. So our two solutions are x equals negative 1/3 and x equals 3/2. Let's look at example number 3. This one's already set equal to 0, so that makes our lives a little bit easier. First thing we want to look for is a GCF. So can I take anything out of both of these pieces? I can take an x out. And so when I pull the x out, I end up with 3x minus 5 equals 0. Now I can't simplify 3x minus 5 anymore. So what I want to do is I'm going to set each piece equal to 0, and that includes the x that we pulled out. So x equals 0 would be a solution, and 3x minus 5 equals 0. The first one we don't have to do anything with because it's already solved for x. For the second one, we want to make sure we add 5 to both sides. And so we end up with 3x equals 5. And the last step is to divide both sides by 3. And we get x equals 5/3. So the two solutions are x equals 5/3 and x equals 0. And let's go ahead and do one more. We have 2x cubed equals 24x minus 8x squared. Again, this has to be set equal to 0 before we can even do anything. So I am going to subtract 24x from both sides and add 8x squared. And so it cancels on the right. And we get 2x cubed plus 8x squared minus 24x equals 0. Do I have a GCF that I can take out? I can take a 2 and an x out. And so what I have left over is x squared plus 4x minus 12. And so we want to break down the x squared plus 4x minus 12. My a is 1, my b is 4, and c is negative 12. And so a times c, we have 1 times negative 12, which is negative 12. So we have to have one positive and one negative number. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. The goal is to get to positive 4, which means that the bigger number is positive and the smaller is negative. So everything on the left is negative while everything on the right is positive. And negative 2 plus 6 gives me the 4 that I'm looking for. So we keep that 2x out front. We bring down our leading coefficient of 1 and split the x's, and then plug in our missing piece of negative 2 and positive 6. The last step is to divide out whatever they have in common, which is going to be a 1 for both. And so we end up with 2x times x minus 2 times x plus 6 equals 0. And then we set each piece equal to 0 and solve. So 2x equals 0. We have x minus 2 equals 0, and x plus 6 equals 0. Let's look at 2x equals 0 first. The only thing we have to do is divide by 2. And we get that x equals 0 is one of our solutions. For x minus 2 equals 0, we're just going to add 2 to both sides. And so we end up with our next solution, which is x equals 2. And then for x plus 6 equals 0, we're going to subtract 6 from both sides. And we end up with x equals negative 6 as our last solution. So this time we got 3 solutions: negative 6, 2, and 0, whereas in the other ones we only got 2 solutions. The reason for that is that in example number 4, the degree of the polynomial was 3 because x was raised to the third power. In the other ones, the degree was 2, so we got 2 solutions. Where example 4, we have 3 solutions for a degree 3.